The Buick V6, initially marketed as Fireball at its introduction in 1962, was a large V6 engine used by General Motors. The block is made of cast iron and all use 2-valve per-cylinder iron heads, actuated by pushrods. The 3800 was on the Ward's 10 Best Engines of the 20th Century list, made Ward's yearly 10 Best list multiple times, and is one of the most produced engines in history. To date, over 25 million have been produced. In 1967, GM sold the design to Kaiser Jeep. The muscle car era had taken hold, and GM no longer felt the need to produce a V6, considered in North America an unusual engine configuration at the time. The energy crisis a decade later prompted the company to buy the design back from American Motors, who had by that point bought Kaiser Jeep, and the descendants of the early 231 continue to be the most common GM V6 as it developed into a very durable and reliable design. Though the pre-3800 RWD V6 uses the BOP bell housing pattern that it inherited from its V8 ancestor, an oddity of both the FWD and a WD 3800 V6 is that although it is a 90-degree V6, it uses the GM 60-degree V6 bell housing. For use in the RWD applications, the bell housings on both the manual and automatic transmissions are altered slightly. This engine has the cylinders numbered 1-3-5 on the left-hand bank and 2-4-6 on the right-hand bank, the number 1 cylinder being the furthest from the flywheel end. The firing order is 1-6-5-4-3-2. The engine was produced at the Flint North plant in Flint, Michigan, with engine blocks and cylinder heads cast at the Gray Iron plant in Saginaw, Michigan. Fireball V6, the first engine in this family, was introduced in 1961 for the 1962 model year Buick Special with Buick's 198 Acclaim engine, the first V6 in an American car. Because it was derived from Buick's 215 Acclaim aluminum V8, it has a 90-degree bank between cylinders and an uneven firing pattern due to the crankshaft having only 3 crank pins set at 120 degree apart, with opposing cylinders sharing a crank pin in, as do many V8 engines. The uneven firing pattern was often perceived as roughness, leading a former American Motors executive to crow it was rougher than a cob. In 1977, Buick redesigned the crankshaft to a split-pin configuration to create an even-firing version. The crank pins associated with the opposing cylinders were offset from each other by 30 degree. The relatively small offset did not require flying arms to be incorporated, however a 3.0 ohm thick flange was built in between the offset crank pins to prevent the connecting rod big ends from walking off the crank pin bearing journal and interfering with the adjacent big end. The 3.0 ohm thick flange effectively caused the connecting rods on the left-hand bank of cylinders to move 3.0 ohm forward relative to the right-hand bank, but the engine block remained unchanged compared to the odd-fire engine. Since the cylinder's center lines were no longer centralized over the crank pin bearing journals, the connecting rods were redesigned with the big ends offset from the piston pin ends by 1.5 ohm. The engine in this configuration became known to have off-center bore spacing. The off-center design continued up until the 1988 LN3 version of the engine, when the left-hand bank of cylinders was moved forward relative to the right-hand bank. Although the actual bore spacing between cylinders on the same bank remained unchanged at 107.7 ohm, the LN3 and later engines became known to have on-center bore spacing. 198, Buick Division, concerned about high manufacturing costs of their innovative aluminum 215 V8, sought to develop a cheaper, cast-iron engine based on the same tooling. They settled on an unusual 90-degree V6 layout that was essentially the architecture of the 215 less 2 cylinders. In initial form, it had a bore of 3.625 inches and stroke of 3.1875 inches, for an overall displacement of 198 Acclaim. It weighed about 35 lb more than the aluminum engine, but was far cheaper to produce. Dubbed the Fireball V6, it became the standard engine in the 1962 Buick Special. In their test that year, Road and Track was impressed with Buick's practical new V6, saying it sounds and performs exactly like the aluminum V8 in most respects. 225, the bore was increased to 3.75 in, and stroke increased to 3.4 in, increasing displacement to 225 in. Since the engine was similar to the popular small block Buick V8 now with a cast iron block and displacement of 300 cubic inches, the engine was made cheaply at the same factory with much of the same tooling. This engine was used in Buick's intermediate-size Special and Skylark models from 1964 to 1967 in Oldsmobile's mid-sized F85/Cutlass models for 1964 and 1965. 1964 to 1965 models featured a one-barrel Rochester monojet, producing 155 HP. In 1966 to 1967, the one-barrel was replaced with a two-barrel Rochester 2GV, giving the engine a 5-horsepower boost to 160 HP. The V6 was dropped after the 1967 model year in favor of a conventional 250 cubic inch inline 6 engine built by the Chevrolet division, and the tooling was sold to Kaiser Jeep. Dauntless, in 1965, Kaiser Jeep began using the Buick 225 in Jeep CJs. It was known as the Dauntless 225 and used a much heavier flywheel than the Buick version to dampen vibrations resulting from the engine's firing pattern. Buick sold the tooling for this engine to Kaiser in 1967, as the demand for the engine was waning steadily in an era of V8s and muscle cars. When American Motors bought Jeep, they replaced the V6 with AMC straight-six engines. Applications: 1966 Euro 1971 Jeep Jeepster Commando, 1966 Euro 1971 CJ5, 1966 Euro 1971 CJ6, 231. The 1973 oil crisis prompted GM to look for more economical engines than the V8s of 350, 400 and 454/455 cubic inches that powered most General Motors cars and trucks during that time. At that time, the only small engines generally offered by GM were built by the Chevrolet division, including the 140 cubic inch OHC aluminum 4-cylinder engine used in the subcompact Chevy Vega and a 250 cubic inch inline 6-cylinder used in smallish Chevy, Buick, Oldsmobile and Pontiac models, whose design roots dated back to the 1962 Chevy 2. One quick idea was tried by Buick engineers taking an old Fireball V6 picked up at a junkyard and installing it into a 1974 Buick Apollo. The solution worked so well that GM wanted AMC to put the engine back into production. However, AMC's cost per unit was deemed as too high. Instead of buying completed engines, GM made an offer to buy back the tooling and manufacturing line from AMC in April 1974, and began building the engines on August 12. With production back within GM, Buick reintroduced the V6 that fall in certain 1975 models, a move made possible by the fact that foundations for the old V6 machinery were still intact at Buick's engine assembly plant in Flint, Michigan, so it was easy to put the old tooling back in place and begin production at least 2 years ahead of the normal schedule that would have been required to create new tooling. The bore was enlarged to 3.8 in, identical to the Buick 350 and Olds 307 V8s, yielding 231 in displacement. 78,349 231s were installed in Buicks for 1975. Due to difficulties with the new fuel economy and emissions standards, the engine produced just 110 HP. This engine was used in the following vehicles: 1975 Buick Apollo, 1975 Euro 1976 Buick Skyhawk, 1975 Euro 1976 Buick Century, 1975 Euro 1976 Buick Regal, 1975 Euro 1976 Buick LeSabre, 1975 Euro 1979 Buick Skylark, 1978 to 1981 Chevrolet Camaro, 1978 to 1987 Chevrolet El Camino, 1978 to 1987 Chevrolet Malibu, 1978 to 1987 Chevrolet Monte Carlo, 1978 to 1987 Oldsmobile Cutlass, 1975 Euro 1980 Oldsmobile Starfire, 1977 Euro 1979 Oldsmobile Amiga, 1978 to 1987 Pontiac Grand Prix, 1976 a Euro 1980 Pontiac Sunbird, 1976 a Euro 1981 Pontiac Firebird, 1978 to 1981 Pontiac Le Mans, 1977 to 1979 Pontiac Ventura, LD5. In 1978, GM began to market the 231 as the 3.8-liter as metric engine. Sizes became common in the United States. The RPO code was LD5, though California emissions versions were called LC6. Starting in 1979, the engine was used in the front-wheel drive Buick Riviera, though still with a longitudinal mounting. Larger valves and better intake and exhaust boosted the power output for 1979. A turbocharged version was introduced as the pace car at the 1976 Indianapolis 500, and a production turbo arrived in 1978. The Turbo 3.8 received sequential fuel injection and a distributorless wasted spark ignition system in 1984. In 1986 an air-to-air Garrett intercooler was added and the RPO code became LC2. The LC2 engine has a bore of 3.80 inches and a stroke of 3.40. The respective horsepower ratings for 1986 and 1987 were 235 HP and 245 HP. The limited production GNX benefited from additional factory modifications such as a ceramic turbocharger, more efficient Garrett intercooler, low-restriction exhaust system and revised programming which resulted in a 276 HP factory rating. The Turbo 3.8-liter was used in the following vehicles: 1978 a Euro 1987 Buick Regal Sport Coupe, T-Type, Grand National and GNX, 1978 a Euro 1980 Buick LeSabre Sport Coupe, 1979 a Euro 1980 Buick Century Turbo Coupe, 1979 a Euro 1985 Buick Riviera S-Type and T-Type, 1980 a Euro 1981 Chevrolet Monte Carlo, 1989 Pontiac Trans Am Turbo. The turbocharged 1987 Buick Regal Grand National GNX was called America's quickest automobile, and the model continues to be collected and appreciated today. LC9, a smaller version of this engine was produced in 1978 and 1979 for the Century and Regal and Chevrolet Monza. The bore was reduced to 3.5 in, resulting in an engine of 196 curie in piston displacement. The RPO code was LC9. Initially this engine produced 90 horsepower, but in 1979 it received the same improvements in the cylinder heads as did the LD5, and therefore power increased to 105 horsepower. LC4, in response to rising gas prices, a larger 252 curie version of the 3.8 LLD5 V6 was produced from 1980 through 1984 and marketed as an alternative to a V8. The bore was enlarged to 3.965 in, yielding an output of 125 horsepower and 205 lb-ft. This engine was used in many large rear-wheel drive Buicks, and in some models from each of GM's other divisions, including Cadillac which offered the big Buick V6 and several models from 1980 to 1982 as a credit option to the troublesome V8-6-4 engine used in 1981 and early versions of the aluminum block Cadillac HT4100 V8 introduced in 1982. It was also the standard powerplant in the front-drive Riviera and Olds Tornado from 1981 to 1984. Additionally, the 4.1 block was used unsuccessfully at Indianapolis for racing. Its only weakness was the intake valve pushrod seals. This was the first naturally aspirated GM V6 to feature a 4-barrel carburetor. Applications Lake 9, a small 3.0L version of the Buick V6 was produced for GM's 1980s front-wheel drive cars. Introduced in 1982, it was a lower-deck version of the 3.8 designed for transverse application in the new GMA platform cars such as the Buick Century and Oldsmobile Cutlass Sierra. It shared the same bore size as its largest sibling, but featured a smaller stroke of 2.66 in. It used a Rochester E2M E2-barrel carburetor and the band code for the engine is E. Applications, 1982 a Euro 1985 Buick Century. 1982 a Euro 1985 Oldsmobile Cutlass Sierra, 1985 Oldsmobile 98, 1985 Buick Electra Lane 7. The Lane 7 is a multi-port fuel-injected version of the LK9. It was introduced for 1985 and used the van code, L. It was replaced in 1989 with the 3.3. Applications: 1986 Oldsmobile Delta 88, 1986 Buick LeSabre, 1986 to 1988 Buick Skylark, 1985 to 1987 Buick Somerset, 1985 to 1987 Pontiac Grand Am, 1985 to 1988 Oldsmobile Cutlass Calais, 3.8 FWD LG2/LG3. In mid-1984, the 3.8-liter LD5 engine was modified for transverse mounting in smaller, FWD vehicles, and equipped with multi-point fuel injection. 1984 to 1985 models used a distributor, and a distributorless wasted spark ignition system was added for all engines produced in 1986 and later. In 1986, it received sequential fuel injection, and it was initially produced in two forms, the LG2 with flat lifters, and the LG3 with the roller camshaft and lifters. The latter was offered in various models through 1988. From 1986, the 3.8 had a revised, crankshaft-driven oil pump which eliminated a long-standing problem with pump housing wear and loss of prime. Power produced by this engine was, van code B, flat lifters, 140 HP at 4,400 rpm, 200 lb-ft at 2,000 rpm. Van code 3, roller lifters, 125 HP at 4,400 rpm, 195 lb-ft at 2000 rpm, 150 HP at 4400 rpm, 200 lb-ft at 2200 rpm. Applications: 1984 to 1988 Buick Century, 1986 Buick Riviera, 1987 Buick Riviera, 1986 to 1987 Buick LeSabre, 1984 to 1988 Oldsmobile Cutlass Sierra, 1986 to 1987 Oldsmobile Delta 88, 1985, 1986 Oldsmobile 98, 3800 V6, Pre-Series I, LN3 naturally aspirated. Introduced in 1988, the 3800 LN3 would later be loosely considered the Pre-Series I, although the older 3.8 SFI was still available that year in some models. Designated initially by van code C, the multi-port fuel-injected 3800 LN3 was a major redesign, featuring changes such as a balance shaft, on-center bore spacing, use of a 3x/18x crank trigger system, and other improvements. This generation continued in use in several GM products into the 1990s. It produced 165 HP and 210 lb-ft. The Lane 3 is very closely related to the Series IL-27 and Series IL-67 supercharged. In fact, supercharger-related hardware can be fitted to an LN3 without changing the cylinder heads. The L27 has a two-piece, upper plenum intake and lower intake. The LN3 is all one-piece. Applications: 1988 to Euro 1990 Buick Electra, 1988 to Euro 1991 Buick LeSabre, 1988 to Euro 1990 Buick Reator, 1988 to Euro 1990 Buick Riviera, Formula Holden, Holden Commodore, 1988.5 a Euro 1991 Oldsmobile Delta 88, Oldsmobile 98, Oldsmobile Toronado, Oldsmobile Toronado Trofeo, 1988 to Euro 1991 Pontiac Bonneville. 3300, a smaller 3.3 L3300 was introduced in 1989 and produced through 1993. It is effectively a lower-deck version of the 3800, with a smaller 3.7er in bore and 3.16er in stroke for 3,340 cc. Like the 3800, it used a cast-iron block and heads, pushrods, and hydraulic lifters. Unlike the 3800, however, it used a batch-fire injection system rather than sequential injection, as evidenced by the lack of a cam position sensor. It also did not have a balance shaft. Power output was 160 HP at 5,200 RPM and 185 lb-aft at 2,000 RPM with a 5,500 RPM readline. Applications: 1989 to 1993 Buick Century, 1989 to 1993 Buick Skylark, 1992 to 1993 Pontiac Grand Am, 1992 to 1993 Oldsmobile Achiever, 1989 to 1991 Oldsmobile Calais, 1989 to 1993 Oldsmobile Cutlass Sierra, Series I, L27 naturally aspirated. The Lane 3 was replaced by the 3791 CCL27 in 1991 to 1992 and produced 170 horsepower from 1992 onward. This engine was referred to as the Series I 3800, or 3800 TPI. In Australia, the LN3 was also replaced by the L27 by Holden, who used the engine in their Series 2 VN Commodore range. However, the Australian L27 retained the LN3's one-piece upper intake and lower plenum. Power was still boosted to 127 a kilowatt for the Holden L27, before being boosted to 130 a kilowatt in the revised VR Commodore in 1993. The L36 made its debut in 1995. Applications: Buick LeSabre, Buick Park Avenue, 1991 Buick Reator, Buick Regal, 1991 to 1993 Buick Riviera, 1992 to 1995 Chevrolet Lumina APV, Holden Commodore, Holden Caprice, Pontiac Bonneville, 1992 to 1995 Pontiac Transport, Oldsmobile 88, Oldsmobile 98, Oldsmobile Toronado, Oldsmobile Toronado Trofeo, 1992 to 1995 Oldsmobile Silhouette. L67 Supercharged. The Series I supercharged engine went through many internal changes and the horsepower changed rapidly between the time it was introduced and the time that the Series II L36 was introduced. The M62 supercharger was manufactured by Eaton, exclusively for the GM 3800 engine. HP was rated at 205 for 1991 to 1993 engines, and 225 for 1994 to 1995 engines. Some of the additional horsepower for 1994-95 engines was gained by using epoxy-coated supercharger rotors to improve efficiency, and a larger supercharger inlet and throttle body. The 1994-1995 utilized a 2.85-inch pulley versus the 2.55-inch pulley used on the 91-93 supercharger. Applications: 1991 Euro 1995, Buick Park Avenue Ultra, 1992 Euro 1995, Oldsmobile 88 LS, LSS, Oldsmobile 98 Regency Elite, Touring Sedan, Pontiac Bonneville SE with H4 UAPO, not badged, SLE, SSE and SI, 1995 only, Buick Riviera, Opt, Series 2, introduced in 1995, the Series 2 is quite a different engine. Although the stroke for the 3.8L engine remained at 3.4 in, and the bore remained at 3.8 in, the engine architecture was vastly changed. The deck height is shorter than the Series I, reducing weight and total engine package size. This required that the piston connecting rods be shortened 1 in, and the crankshaft was also redesigned. A new intake manifold improved breathing while a redesigned cylinder head featured larger valves and a higher compression ratio. The result was 205 HP and 230 lb-aft, better fuel economy, and 26 lb lighter overall weight. This 3800 weighs only 22 lb more than the all-aluminum high-feature V6 that currently dominates GM's 6-cylinder applications, despite being an all-cast iron design. The new intake manifold greatly improved airflow. To meet emission standards, an EGR tube was placed in the intake manifold to reduce combustion temperatures. The 3800 Series II was on the Ward's 10 Best Engines list for 1995 through 1997. GM recalled 1.5 million vehicles with this engine on April 14, 2009 due to risk of fire from engine oil leaking under the valve cover gaskets onto hot exhaust manifolds. The fire could spread to the nearby plastic spark plug wire retainers on the valve cover and then to the rest of the engine compartment. GM fitted the affected vehicles with redesigned spark plug wire retainers. These engines were noted for having problems with the plastic upper intake manifold cracking around the EGR passage. The engine would then hydrolock. The lower intake gaskets and upper intake manifolds were revised, correcting all these issues. L36 naturally aspirated. This engine was used in the following vehicles: 1996 to 2005 Buick LeSabre, 1997 to 2005 Buick Park Avenue, 1996 to 2004 Buick Regal LS, 1995 to 1997 Buick Riviera, 1995 California Oni, 1996 to 2002 Chevrolet Camaro, 2000 to 2005 Chevrolet Impala, 1997 to 1999 Chevrolet Lumina LTZ, 1998 to 2005 Chevrolet Monte Carlo, Holden Commodore, Holden Caprice, Holden Ute, 1995 to 1999 Oldsmobile 88, 1998 to 1999 Oldsmobile Intrigue, 1996 to 1998 Oldsmobile LSS, 1996 to 1998 Oldsmobile Regency, 1995 to 2005 Pontiac Bonneville, 1995 California Oni, 1996 to 2002 Pontiac Firebird, 1997 to 2003 Pontiac Grand Prix, L67 Supercharged. The L67 is the supercharged version of the 3800 Series II L36 and appeared in 1996, 1 year after the normally aspirated version. It uses the Eaton Generation 3 M90 supercharger with a 3.8 inches pulley, a larger throttle body, fuel injectors, cylinder heads, and lower intake manifold than the L36 uses. Both engines share the same engine blocks, but compression is reduced from 9.41 in the L36 to 8.51 for the L67. GM listed the engine output as 240 HP and 280 lb-ft of torque, although broad torque span and perhaps conservative rating by GM due to the engine's temperature sensitivities, have established a belief in higher actual output. Final drive ratios are reduced in most applications, for better fuel economy and more use of the engine's torque in the low range. Like most 3800 V6s, the engine is well known for its reliability and low maintenance costs. The engine is a popular choice for aftermarket modification thanks to its very strong internals and impressive power gains from basic upgrades. The engine was built in Flint, Michigan and was certified LEV in 2001. This engine was used in the following cars: 1996 a Euro 2005 Buick Park Avenue Ultra, 1997.5 a Euro 2004 Buick Regal GS/GSE/GSX, 1996 a Euro 1999 Buick Riviera, 2004 a Euro 2005 Chevrolet Impala SS, 2004 a Euro 2005 Chevrolet Monte Carlo SS Supercharged Intimidator SS, 1996 a Euro 1999 Oldsmobile 88 LSS, 1996 a Euro 2003 Pontiac Bonneville Sci. 1997 a Euro 2003 Pontiac Grand Prix GTP/GTX, 1996 a Euro 2004 Holden Commodore Versus, VT, VX, VY, 2001 a Euro 2004 Holden Monera Cove 6, Series 3. The Series 3 motors include many changes. The upper intake manifold is now aluminum on the naturally aspirated models. Intake ports are mildly improved, 1.83 inches intake valves and 1.52 exhaust valves were introduced in 2003 engines, just before switching to Series 3. Electronic throttle control is added to all versions, as is returnless fuel injection. Stronger powdered metal sinter-forged connecting rods are used in 2004 plus supercharged, and 2005 plus naturally aspirated engines, instead of the cast iron style from Series 2 engines. Emissions are also reduced. In 2005, it was the first gasoline engine in the industry to attain SULEV emissions certification. Also note that Series 3 engines are the base for any 3800 produced for the 2004 year and up. This means the same block, heads, and connecting rods apply to any remaining Series 2 engines made after 2004 also. The difference is that Series 3 engines received the new superchargers, intake manifolds, fuel systems, and electronics. L26 naturally aspirated. The L26 is the Series 3 version of the 3800. It is still a 3.8L design. Compression remains at 9.41 as with previous L36s, but the aluminum upper intake and stronger connecting rods are the primary physical changes. The powdered metal connecting rods were meant to be introduced in 2004 along with the L32s, but the GM plant in Bay City, Michigan that supplies the Flint, Michigan plant could not achieve the desired production dates in time for that engine year. This engine was used in the following vehicles: 2004 Euro 2008 Pontiac Grand Prix, 2005 Euro 2009 Buick LaCrosse, 2006 Euro 2008 Buick Lucerne, L32 Supercharged. The L32 is a supercharged Series 3. Introduced in 2004, the main differences between the L67 and the L32 is the L32's electronic throttle control, slightly improved cylinder head design, and updated Eaton supercharger, the Generation 5 M90. Power outputs is up to 260 HP in the Grand Prix GTP. As with the L67, premium fuel is required but, the PCM can compensate for the octane difference, although acceleration will be affected by this. The use of less than 87-octane fuel can and does cause detonation that eventually leads to engine damage and failure. Applications: 2004 Euro 2005 Pontiac Grand Prix GTP, 2006 Euro 2007 Pontiac Grand Prix GT, Special Editions, Discontinuation. Production of the 3800 V6 engine officially ended on Friday, August 22, 2008 when Plant 36 was closed. There was a closing ceremony and speakers who extolled the virtues of the engine. Originally GM had set this date for January 1, 1999. However, due to the vast number of complaints from both investors and customers because of the popularity and reliability of the engine, the date was extended. At the end of production, the LZ4 3500 OHV V6 replaced the naturally aspirated 3800 applications, and the LY7 3.6L DOHC V6 replaced the supercharged 3800 applications. See also, Buick V8 engine, list of GM engines, references. External links: Full Throttle V6, your source for GM V6 tech. 3800tech.net, a website for all 3800-powered GM vehicles under maintenance since January 2012, brief early history of the engine, and 3800 history page at CanadianDriver.com, L67 engine swap page for various vehicles.